and just that kind of thing, just a pretty open discussion. If that sounds good.
Yeah, sounds great. Do you want to do a quick intro for the developers you have in the room? Let them introduce themselves.
Sure, we'll do. Okay.
Hi, Bert. It's Nathan here. So I'm one of the developers here at GenB. I actually had the opportunity of going through to the OpenMRS conference last year. So I have a little understanding of how it all works, but still fairly new to the whole system.
Okay, hi, I'm Dane here. Recently started with GenB, the whole OpenMRS is so new to me, so I would hopefully have a lot of questions.
I'm Rowan Blay. I work on our thesis team.
It's blood safety information system. It's a blood strengthening program, blood donor management.
Cool. Yeah, and I'm just interested in OpenMRS, so glad to be able to join.
And that's all.
Okay. Other folks on the call want to introduce yourself?
I'm Wycliffe here. I'm one of the OpenMRS developers.
Oh, it's Joseph, GMB.
Karina Matilde from Mozambique, UCSF.
Ali Habib from IHS. I heard there was a data model related call, so I'm here in case I learned something new.
All right, excellent.
Also from UCSF from Mozambique.
Welcome.
Here is Mino Neves. Here I am represented in Mino Neves. I'm from Mozambique, UCSF.
Welcome. All right. Let's see. I also see Lars, Meg, so a few others. Welcome. I know maybe not everybody has voice, but just wanted to let you know. This is OpenMRS University. We are asked to do a kind of a deep dive into the data model. So let me start a screen recorder, so in case someone wants to subject themselves to this in the future, they're welcome to. Oh, okay. Sorry, I'm gonna have to switch real quick to an old-fashioned headset because I can't record with a Bluetooth headset on. I forgot that. So forgive me for just a second while I switch headsets. All right, so I Can folks still hear me?
Yes, we can.
Okay, good. Sorry for that. All right, so welcome to OpenMRS University. This is, the topic is a deep dive into the data model. So I'll do kind of an introductory kind of walkthrough in terms of the OpenMRS data model. Hopefully we can spend just maybe the next, the first 10, 15 minutes or so in terms of just kind of try to get everybody on the same page in terms of the data model. And I'm sure there's additional discussion we want to have beyond kind of that introductory space. So the data model, first off, OpenMRS is, as I think most folks know, it was built as a Java-based web app, and we chose, when we initially started, we chose to use MySQL because it was openly available, an open source data model or database engine, and it was both popular but also had a lot of decent UI tools and tools to work with the data model relative to other competitive data engines like Postgres. We thought at the time that it was both very popular and the tools to work with it were not as complicated or didn't have as high a requirement in terms of developer or admin skills. So we thought the choice at that time was to try to make it the data accessible to folks as we shared a platform. So that's a SQL or SQL based relational data model that database engine that we were building in. OpenMRS does use a object relational mapper, or ORM, called Hibernate. That's a Java library that translates from Java objects to relational databases, and that is our that's a lot of the actual creation of SQL statements from OpenMRS, the platform, is done through Hibernate, so as to kind of not force us to be MySQL specific. Theoretically, folks should be able to run, again, using Postgres or SQL Server or MariaDB or other types of databases. But we won't really get into, I don't think, into specific database engines here, just to talk about the relational data model and how things are structured. But I thought I'd give a little bit of background there. So someone getting interested in or wanting to learn about the data model, the best place is not my Chrome history, but let me put it on a OpenMRS/data model. So this URL, OpenMRS/data model, will take you to, if I can type it in my browser, will take you to the OpenMRS wiki and to this data model page. The page kind of gives you a brief introduction to the data model, has links to images, and kind of gives an overview of what the structure of the data model is. Some of this is a little bit dated because creating these images takes a fair amount of effort, and so it's only when someone finds the extra time to lay these out that we get a new data model image. I think, let's see if I click on this image, if I can get let's see if we can get a bigger image of it. I think probably downloading it is going to give me something that I can share. So you can see this is, there's a lot here. And actually, It's a lot to absorb when you come to it. I can tell you when we started out with OpenMRS, actually I think I might be able to pull up from from my computer one of the earliest data models I can find. Let's see here. So you can see, this is, I might have something older than this, but you can see that the data model has gotten a little more complex over time. Even this model feels fairly heavy duty, and this was back in 2005. We started out with basically a observation table, a patient table, I think a user table, an observation table, and a concept table. And so we'll get into, let me kind of get into those different regions. But as a starting place, I wanted to share, there's a few slides I've made and shared with folks before to explain our general approach to a lot of the data in OpenMRS. Can folks still see my screen? Can you see the slide on stacked model?
Yes, we can.
Okay. So, all right, so let me go back to the front. So the typical approach, and that what we saw all over the place in terms of approach to building database systems, and when Paul and I went to Kenya in around 2004 to try to help them move or scale up their system, which they had started in an Access database. It was this typical spreadsheet approach to data modeling, where you want to know your patient, and you want to know what's their pulse, what's their weight. Maybe later on, you want to know what's their CD4 count if you're treating HIV. And what ends up happening is that as you want to collect more data, what drugs are they on, or other information about them, every time you're adding information, you have to change your underlying data model. And it's what I often call the spreadsheet approach. It's very simple to get your mind around. It's just basically building a spreadsheet, and you just add a new column every time you have a new concept. And that's the typical kind of initial approach to people creating data models. The problem with it is that you can't really scale out, and you can't scale. One thing that as you get into medicine, if someone's new to the world of medicine and informatics in medicine, is you learn that the data model is actually changing all the time. And medicine, our knowledge of it and what we know to test, even for diseases that have been around forever, like TB, we learn new ways of making treatment better. New tests come along that work differently, and so the information and the model of that information is constantly in flux and changing as hopefully we get better and better at taking care of patients. And so we can't afford to have, especially if we want to share a platform, we can't afford to be making major changes to the data model every time a new concept comes along. So the approach from the beginning with OpenMRS was to introduce a concept dictionary. And the concept dictionary is a table itself, which basically has the notion of there's a concept and maybe some information about it, maybe units or value ranges or what type of data it takes. Does it take a numeric result or a date or maybe another concept as an answer? That metadata, we define that in a table we call the concept table or the concept dictionary. And the notion of that is that we're making a meta table, metadata about what is our medical data model. And so each entry, say it be pulse or weight, is entered in that concept dictionary. And then we use if you're a programmer, you may have heard of EAV as a model. It's entity attribute value, and that's the approach we use, which is instead of making a new column in the table every time we have a new concept or something new we need to record, we create a table that says who's the patient, what is the thing that we're asking about or we want to record data for, and then what is the value for that thing. And what you'll see is that now instead of putting, say, pulse or weight in our table, in our data model design, we actually are recording that as data. We're saying, okay, the patient's John Doe and his pulse is 80. We can record that without having pulse anywhere in our data model. And so what ends up happening is that when we want to add a concept, so we have pulse and weight, and let's say we want to add, I think it's CD4, we can just make a new entry in our dictionary. So now we've told the system there's a new thing called CD4 count, and here's what you need to know about it. And we can go back to the data table where we're going to record that, and instead of having to add a column for CD4 count, we can just add a new entry and say John Doe, and in this case, the question we're asking or the test we're doing is a CD4 count. That gets recorded as data, a new row in that table. It's more of a growing vertically instead of growing horizontally approach, but that allows us to scale and allows us to make changes. And that's why at the heart of the OpenMRS system, you'll see a concept dictionary and you'll see observations as one of the primary ways that we collect data in the system. So that hopefully that's a relatively easy way or easy introduction to people of why you're seeing at the heart of this a concept dictionary and how observations are stored as in that EAV approach. So I'll move on to some of the domains and kind of how the different types of data we're collecting in the model, but I want to stop for just a second. Do folks have questions about that?
Thanks, Beck.
All right, so feel free to interrupt me if I start going off and talking about something that either is of zero interest or is confusing. So let me jump into the kind of domains of the data model. So we'll start out looking at this. What is, I know it still looks complicated. When we started with OpenMRS, we actually had a fully vetted kind of data model available to us at Regan Street, but it looked a lot like this or even more complicated than this design. And we looked at it and it was like looking at a bowl of spaghetti, and we said, there's no way, we can't handle this. So we Paul and I, being cavemen, were like, we just got to start with the pieces we need, and we started developing. What we started with, as I think I mentioned, was there's patients.
Welcome to OpenMRS. Write code, save lives.
This conference is being recorded by the organizer.
An observation, and for observations, we knew we wanted that EAV model, so we needed to have concepts defined. So we started out with the notion of a concept dictionary, creating obs or observations about people, and which are the data, their pulse, their height, their weight, how many children they have. It could be any piece of information you want to collect, and then basically the patients, the users of the system, and then we also had let's see, the encounters. And so encounter was the notion of you collect the data, you collect these observations about a patient, but in life, it's not like you just always are just picking up data about people constantly. And our world is changing to move more closer to that model, where with personal health data and other ways of collecting data, we're moving more toward a stream. But in typical clinical care and what we were treating at the time, in most cases, this was outpatient treatment where a patient would come to a clinic and have a bunch of questions or tests done and then leave. Maybe some plans were changed in terms of how to treat the patient. And so there was this episodes of care that would happen. And so we borrowed the term that is very common in medicine of an encounter. And that is essentially encounter as a grouper of observational data at a point in time. So encounter started out representing that patient comes, sees their doctor, and that's an encounter. And in an encounter, you might have 1 to 100 or 1 to n observations collected. And so we have patient, we have encounters with the patient, we have observations. The doctors and the people that are working with the system are the users of the system. and at the center we have this concept dictionary. And then you'll see we introduced forms as a way of collecting data. So we started to enter information about what questions do we want to ask, when we wanted to be able to represent in the system those encounter forms, and not just collect the data, but also help build some of the tools to help collect the data. And so that's, forms were introduced. Later on, we came up with adding orders to try to allow for collection of orders like drugs or tests that the doctor wanted. And then there's some other tables that are kind of helping in terms of development or maintaining the system. So we can dive into these. I wanted to show you these buckets, the colored regions are those basic domains of patient, the encounters with patients, users, the concept dictionary in the center, and observation data. That's the main pieces of the data model. This is an old data model. We'll go to a newer version of the data model. You'll see those same buckets. So at the center is the concept dictionary, and there's a bunch of tables. We'll come back to that. We should find the same basic groups. So here's patient at the top. So these tables represent information about the patient. We later on introduced the notion of person because we needed to collect not just information about patients alone, but also family members, and so person became something underneath. Every patient obviously is a person, but so users can be people and providers can be people, and so there's person gets reused not just for patients. So there's general information about people now. Users are still there. We still have the form table and the tables for forms. Orders has kind of evolved. There's still some business tables behind the scenes. And here's our observation tables. And this is, I think, our encounters. And we actually, I don't know if it's it doesn't look like it quite made it into by 1.9, but around the time of 1.9, probably just after this particular view was made, we introduced visits. And so a visit, you'll see as you get in, start working with the data model and data within OpenMRS, and the distinction in our world, in the OpenMRS world of encounter and visit, is an encounter is thought of as a point in time encounter, whether it be the patient with the doctor or the patient with a nurse or patient with going to the lab to have some data collected. An encounter is kind of thought of as a point in time transaction or interaction between the healthcare system and the person or the patient. And visit was introduced as a grouper that we realized that we had these encounter forms where people would collect data about a patient, and but it wasn't. Initially, it was one encounter form when the patient came to the clinic, and what we started as we grew, we realized that we had times where maybe more than one encounter form or more than one encounter with a provider was happening. Maybe the patient would come to the clinic, but they would go to the lab, then they'd go see the nurse, and then they go see the doctor, and each one of those may generate an encounter. And so visit became that, not necessarily one event in time, but the grouper to say a patient comes to the clinic, that's a visit, and a visit may have one or more encounters within it. And so when you see visit in the OpenMRS world, that's referring more to the physical patient came to the clinic. It can also represent a hospital stay. So the patient might get admitted to the hospital and they may stay in the hospital for 3 days or 3 weeks. And visit could encompass all the encounters that happen during that entire stay. So whether it's an inpatient in the hospital visit or an outpatient clinic visit, that the visit in our world is used. If you look at other systems in the world of medicine, like FHIR is a very popular standard now for a way of representing information. They actually use encounter to cover both what we think of as encounter and visits. They use encounter just generically to represent either a one point in time or the grouper. And the way we've evolved, we distinguish those a little bit between encounter and visit. But I think that's probably enough time on that notion. So I think I'll stick with this diagram for a second in terms of just being able to see how these tables are related. This is a lot of information when you go looking at our concept dictionary, but we won't obviously cover every detail of these, but we can give you maybe a little bit of a deeper dive into some of these domains. Personally, I think the valuable ones are to understand kind of how concept evolved and what the data model looks like for concepts and how that reflects, some of the details and observations. And then we can do maybe a high-level run-through in terms of persons and providers and users in the system. Will that be helpful to folks, or are there, before I dive in further and keep just talking, are there other things that folks would like to get out of the kind of this overview?
Burke, I think for us, just talking about reporting.
Okay.
And
So you're interested in the kind of reporting side of it. Okay. Yeah. So reporting is a little. So I'll do kind of a high sweep over kind of how data are represented, and then we can get into kind of how that affects reporting. And I think we can talk a little bit in terms of how reporting is used. I don't know if I have, in terms of the reporting data model, I may have some of that, so I'll try to jump to that. Any other comments or what folks want to hear in terms of the data model? Okay, so with a mind of not getting into the weeds too far and jumping toward getting the conversation toward reporting sooner than later, I'll just say, in terms of the concept, you can see there's a lot of tables that describe concepts. We moved from this kind of initial notion of just one or two tables for concepts. Now we have we separate out names and descriptions to allow for localization of them. We have mapping to reference terminology, and we have ways of representing different types of concepts. Like numeric concepts have some additional metadata that's collected about them. We also have drug is getting more and more used, and drug is meant to be kind of a reflection of what the pharmacy's inventory of drugs are and how those relate to the concepts. So in our world, everything is essentially a concept, and that includes the medications you're going to prescribe for a patient. And so essentially the drug table is a way of saying if there's an ampicillin tablet, that we relate that to the concept of ampicillin as a drug, and so that's part of our concepts table.
So Burke,
yeah.
So that drug table seems to be like the only thing in there that's not completely generic. And why is that? What's special about drugs?
Yeah. So one of the things we wanted to be able to handle is very common when folks are wanting to start prescribing medications for patients, that they want to be able to say, not just, in the concept table, we were initially just collecting information, maybe passively or not necessarily thinking that people were going to name specific drugs, but say, okay, there's ampicillin and there's maybe the active ingredients that are really the treatments for that are of concern for taking care of patients that but we weren't. We were doing more data collection and not so much point of care writing out prescriptions. And so the concept dictionary started out as being sufficient for just capturing information about medications. But as we grew and as the needs grew around in the community for tracking drugs, both prescribing and tracking more details about not just that it was ampicillin given to the patient, but it was a 500 milligram tablet of ampicillin. That's where one of the things we struggled with is when you get into the space of drugs in medicine, there is an ever-changing and very kind of implementation specific. Sometimes even at a single site, there may be patients that are on one care plan or one insurance or have a certain type of coverage, and they can get some drugs of different formulations, and other patients may get other formulations. It gets very complicated and messy, and it gets very specific to the different forms of drugs. And we didn't want to be in a world where every time someone had to name ampicillin in this formulation that they had to make an entry in the concept table, because that's just not scalable. A lot of the concepts we strive, and CIEL, the CIEL dictionary, is very popular amongst implementations of OpenMRS as a shared concept dictionary. And it's very helpful, especially when you try to move data between systems, to have kind of a shared view of the world in those concepts. That is much harder to do at the specific drug level. And so trying to create a process where every formulation of every drug would have to be in the concept dictionary just was not viable. We are looking, though, we knew that there's also smaller implementations where maybe a doctor is going into a clinic and just has a tackle box, has a small box with 3 drugs available to them, and they may not need anything fancy. They have their 3 drugs, and making a concept for each is sufficient. So what we introduced drug, and normally this would probably sit maybe outside the concept dictionary, or it could. The reason it's here and doesn't look as generic is we're trying to have our cake and eat it too, which is basically for smaller implementations where all they really need is they have 3 or 5 or maybe 10 drugs, and it's they have a 500 milligram ampicillin tablet, and they have the other 10 drugs that are in their box, and that's all they need to track. They can make one-to-one relationships between concept. They can have a concept for each drug, and that's fine, and that may be all they need to get by. For larger implementations, we assume that you will probably just have the main ingredient like ampicillin as a concept, and then the drug table would have maybe 4 different formulations, different forms of that drug, a different tablet or capsule, etc. And so we haven't, we didn't, especially when we introduced this, have the full order entry, and that's still in evolution. There's also not one way that people share pharmacy systems, and so drugs are in the purview of a pharmacy system, and so this drug is a little bit of a ugly duckling in the model in terms of trying to be a shadow of what would normally be within the purview of a pharmacy system, in terms of here's our inventory of all the different tablets and what we have available. And the reason it's important in a medical record system is that a provider would come and say, I want to give ampicillin, and we want to be able to tell them, okay, well, you can give the 500 milligram tab or the 250 milligram tab. So having these data available within the system are very helpful in terms of that interaction. I don't know if I'm answering your question, but.
Well, Burke, I also have a question regarding to this drug table. I'd like to understand, what is the main purpose of these tables? As we see on the drug table, we also have, let's say, a relation with a concept. So are we going to use this table to, let's say, specify a drug? For instance, if we have a paracetamol, we can have a paracetamol as a general term. If we want to specify which paracetamol are we talking about, is this table that we're going to work through? Or
yeah, so this is not drug is something. This table in particular is not something that I run around projecting as, oh, this is my favorite part of our data model. It is, I would consider it still a little bit of a work in progress, but the intent of it and the way I would recommend in terms of approaching it is like you suggest. If you have paracetamol, that would be, you might have the concept of paracetamol. That is the active ingredient, the thing that in terms of understanding what drugs the patients are, what's affecting the patient, or for tracking allergies and things like that. You you want to know about that concept of paracetamol. The drug table would be for the specific formulations of, there's the, maybe there's the 325 milligram tablet, and there's the 650 milligram tablet, or the 500 milligram tablet. So I would use drug to say, this is essentially the inventory of types of drugs that are either paracetamol or maybe a combination drug that has paracetamol in it, and then link those to the concept of paracetamol. Because when the reason for creating those are one is that the inventory of what formulations you have available can be a moving target, and really is in the realm of pharmacy to manage, not so much while it's very helpful for the EMR to have those data available so that it can help in terms of directing people on ordering and understanding what forms are available. It's not really the EMR's job to manage what inventory is available in the pharmacy. And so I look at this, when I look at the drug table, I see it as almost a shadow of, like a footprint of, in an ideal world would be, the pharmacy would be in control of this table, and they would say, okay, we have our separate pharmacy system, and we know what inventory we have, and in 6 months from now, maybe we don't have that form of paracetamol available anymore, and we have a new one, that they would have, the pharmacy system would be tracking that, and they would be updating this table accordingly in terms of, letting the EMR know, hey, this is what's available, and how that relates to the basic concept of paracetamol or the next drug, ampicillin or whatever, in the system. And also when someone's ordering a medication, it's not very efficient to say, here's our entire inventory of medications and we're going to let you search that. In small settings that may work, but in large settings where you have maybe hundreds or thousands of drugs available and there's multiple forms of each one, it's often more efficient to let the provider say, I want to order paracetamol, and then show, oh, here's the forms of paracetamol available. And so that separation also helps in that interaction. Did I help answer any of those questions?
Yes, I'm clear now. Thank you, Bert.
So for the sake of time and getting into reporting, so that's just, the concept is a fairly important part of the data model. I think also even in the world of reporting, OBS is probably a pretty big one. OBS is, you'll see, has all these separate values. This was a choice we made fairly early on in the world of OpenMRS, and that was, we had the choice of either saying we're going to have observation, we're going to collect the data we want for the patient in terms of whether it's pulse, weight, how many children do you have, is Paula Dork, yes or no. No matter what the question you're asking from the patient, when you want to record those data, those go into OpenMRS's observations. And we had a choice early on of, do we just say, here's the question and here's the answer, and knowing that answers may be a date, it might be a number, it might be another concept. So like if you ask, what's your marital status? Are you married, divorced, single? In the world of OpenMRS, the answers of married, divorced, or single would not just be free text. We would prefer those be concepts as well, and so we call those coded answers. So we know some concepts, some observations will have coded answers, some dates, some numeric, and the choice was, do we make a single field that's a string, and then every time we're going to interpret that, we have to parse that and make sure we understand it as, like if we want to scan for dates, we have to be able to take strings and turn them into dates? Or do we want to do the codification or separate them into separate bins. And for the sake of performance, early on with MySQL, we decided that it would be more effective to have separate bins for them. And so this was purely an early design. And the notion is that for an observation, ideally it should have just one of these values filled in, whether depending on the data type of the concept. It's either a coded concept, it's maybe it's referring to a drug, or it's a numeric value. Ideally, the concept, that's the question that's being asked, would determine what data type it is, and then the value would be in the corresponding data type. And that's, I think, when especially if you're down at the SQL level or you're doing transforms with these for reporting, that's one thing that you would have to deal with, is the fact that the bucket the value is in is going to depend on the question being asked and what data type it is. I think that there's probably not a whole lot of other insights into. I talked about visits and encounters and how those relate. It's interesting, visits and the patient. I probably wouldn't have put it that. Would have put it in the encounters. I found it. Patient is relatively straightforward, and person. One thing we do is one thing that we do with patient is that we have identifiers or medical record numbers, and so that's a way of tracking essentially the records for a patient. Those are intended to be a unique way to identify the patient. There's a whole conversation that can happen around that, but we won't have it right now. In persons, there's information that we collect from persons are names, allowing more than one. Same with addresses, and then you'll see in the data model, and this could come into play if you're trying to do reporting off the data model, is that we have several places where we have attribute tables. And so, in a typical data model or relational data model, the table is this object, and then each of these are considered attributes. Early on in our use of the system, we realized that we're trying to be a platform used by a lot of different implementations, and we're not going to get everything exactly right for every implementation. There's not one design that meets everybody's needs. And so we have to introduce the notion of attribute tables as essentially a way of extending the core tables. So when I see a table like person attribute and person attribute type, what in my mind I see these as being metadata allowing an implementation to, for their local needs, extend the person table. So in our case, like in Tanzania, they have 10 cells where they record or they track a person lives within a group of 10 houses. And that's fairly unique to that region and not something that everybody needs. Attribute tables is a way that they can say, okay, well, we want to add, for every person, we want to have a 10-cell reference. They can add that as a type of person attribute and then start recording for their people in their system. This is what the 10-cell they're in. And that allows them to effectively add a 10-cell column, an attribute to the person table without us having to make everybody have that in their database. And you'll see those elsewhere. I think you might be able to find them, like visit attribute is doing the same thing for visits, allowing that to be extended. You'll see that elsewhere in the system. Yeah, I don't know if there's other lessons. We do have a basically role-based access and control, meaning we have privileges and roles that are designed and meant to control who can see or use different parts of the system. We have never really effectively designed that in a way to say, here, this person can only see these data. That's still on our wish list to do that effectively and without losing too much performance. But we do use roles and privileges to control this person cannot look at observations, or this person can look at them, but they can't edit observations. Roles and privileges manage those types of like what behaviors a person can use in the system. So we can get into reporting. Other thing I wanted to point out as a resource is I pointed out that OM.RS data model is a URL for getting to the wiki page. There's another tool that I use a lot. Maybe I'm a little biased to it because it was the tool I made, but it's available at om.rs/dm, just short for data model. And if you visit that URL, om.rs/dm, it's just a simple tool I made for, and I need to update it with more recent data models, but it's a simple tool for just viewing and searching the database. And so as you get in and you're looking and like, wait a minute, what about this for the data model or that about the data model? I find that this is, if you type help or hit the question mark, you'll get some helpful information in terms of how to use it. It's basically just using JavaScript and lets you do regular expressions to search the data or attributes. But for example, if we wanted to see the user table, I can just type user. If I put a $, well, it's users. If I put a $sign at the end, because it's regular expressions, I can constrain it just to that one specific table. But you can do things like you can look for table dot attribute, and it'll highlight those. You can just attribute. You wanted to look for just how many tables have something with an attribute that starts with F, and I can find all of those quickly and easily, and there's a link that you can use to share. So anyway, just FYI about that tool. I think it's a handy way to quickly scan the data model. Anyway, so in terms of reporting, I don't know if we have some of the reporting tables in the latest data model, and so I can show you in this form. Reporting, and I don't know if this is the detail that you want to get into, but one I know a common approach in the reporting framework that is within OpenMRS, and Mike Seaton is probably much better as a resource in terms to explain how some of the reporting works under the hood. But I do know at a high level that a lot of the objects and things, reporting definitions and things that are used in reporting are serialized and then stored as just generic report objects. And I think essentially they get a name and a description, a type, and then the data, actually the serialized data, is stored in this column, in the XML. And so I know a lot of what happens in reporting is stored in these serialized XML objects. But I think probably it might be more effective if myself or Wycliffe can try to address specific questions, since we're down to we've already, man, I can talk way too much. I apologize for that. I can't believe it's already 10:50. So let's get to specific questions folks have. We have about 10 minutes left, and we can try to cover any questions. And if you don't have a working mic, you can also, there's a chat on the side. I think it looks like, I can get it to close. It's this little bubble on the side. You can open that up and you can enter a message down at the bottom. But if you have a working microphone, feel free to unmute and ask questions.
Method that people use to make the report a little bit easier is that, are those reporting tables really the main kind of method that the reporting module uses, or do other people use other ways of maybe creating materialized views? Or
so there's a kind of a built-in and distributed reporting framework that's provided by a few modules that we distribute, and I think those were designed Mike Seaton was kind of the lead on that, and driven by reporting needs across the different sites that Partners in Health uses. And we're so lucky to have Mike and his team, a lot of the programmers through Partners in Health that have contributed to OpenMRS, because they have a way of not just trying to solve their immediate need, but thinking in the bigger picture of how can we build something that will help us and maybe help the next person or help us in the future, to design things that are a little more generically useful than just fitting the immediate need. And that has, I think, helped them, but also been very beneficial for the community. To that end, the reporting module, the reporting framework has been around for a while, from earlier versions, very early versions of the OpenMRS data model. And it was designed as part of that Java server-side code to allow people to create definitions or essentially calculations off the data. And the approach Mike took is one where it was the real meat of it, the power of it, is there's interfaces and some fairly generic approaches to creating those definitions. They do require development chops. I mean, to go and implement an interface or two in terms of create a new Java class, but it's very flexible in terms of the design for reports that you're going to need to do frequently. I think the reporting framework can be very useful. There are some tools built around it to allow people to build up and create reports. I think without do at least some basic reporting without having to do programming. And I think also Mike's approach was that he could program, maybe implement a few classes that implement reporting definitions to make certain, more, reporting, the report definitions essentially are like the columns in a report, to make new ones available and then allow people through a UI to pick and choose from those, and so create their reports. So it wasn't that you had to have a programmer to create the entire report, but to maybe define some of the new columns needed for the report. So that has been around for a while and is used by a lot of people as a way. It has the limitation that it is going directly off the relational tables. It's using, it's depending on the SQL largely, and it depending on your reports and how you code those, can have either minor or very major effects on performance of the system if you run reports that have to look through a lot of data, and if your queries are not written in a way or are written with the not as efficiently, you can easily manage to bring your system to a crawl using that approach. So there have been other approaches to dealing with reporting. We've had several starts and efforts that have worked with business intelligence tools, from Pentaho. I know that was one of the early ones and one we've worked with before, but I think others have been used as well. And the challenge, in my perspective, of when it comes to reporting is the typical kind of star schema kind of reporting warehouse approach of that is the traditional approach maybe 5-10 years ago is one where if you know your questions and you know your data model, there's a fairly straightforward way to apply that. As we talked about from very early on, the data model in medicine is constantly moving, and typically we're not in a place where, like a banking industry or something, where we have 3 reports we need to do or 100 reports we need to do, and we know what all the questions are and we have a fixed data model. We're in a world where people are always coming up with new research or treatment questions, and so the questions are constantly changing and the data model is constantly changing. And when I say the data model, I don't mean just the OpenMRS data model, but the data itself, the concept dictionary. And I think the newer tools like Lucene and Hadoop and all the various tools that have come out with, whether it's NoSQL or it's essentially trying to solve that problem of I just want to throw a bunch of data into a database and be able to ask any question. And that was kind of magical speak probably 5-10 years ago, but with the tools, and these are becoming more commodity, I think that's I think we're getting to a place where or have gotten to a place where if someone had the time and could build out those tools, we could do much more efficient reporting. And there's been some efforts in those areas. I know AMPATH built essentially an ETL process, but it's fairly specific to AMPATH right now. But they basically transform data from the system. They actually transform it into SQL, but into kind of essentially essentially into flat tables that are may have redundant data through them, but are efficient for reporting needs, and then run reports off of those. And that has been very helpful for them. I think my bias would be that using Lucene, using tools like Kibana, my hope would be is that we could come up with a more generically useful approach. But that there's interest and there's some various efforts of people starting to push that direction. I don't think we have I don't think we've had yet a place where someone said, I'm going to create that in a way that benefits everybody, and so we don't have that kind of NoSQL in the ideal world. It would be something that we could distribute. It'd be easy to set up right next to OpenMRS, and it would bring a Lucene-based engine for searching. There's the chart search kind of tries to do some of that under the hood for just basically searching, but it's not a big leap to start to take that approach and leverage it for more generalized, more report, not like one patient search, but to search across patients. So I think there's interest in, and a lot of different folks in a newer kind of using other tools to power reporting beyond what the reporting framework can do. And the truth is, the way the reporting framework is working, they could benefit from each other, because the reporting framework could go to that ETL solution and pull out data for reports. For some of those monthly reports, you might run it and have it done through the reporting framework, but also including data that from your ETL solution. So right now there isn't okay, everybody's using this one ETL solution that I could point you to. If it exists, at least I'm not aware of it.
Great, thanks very much.
But I'm very interested, and that's one of the spaces that I would love to help. I've seen various people kind of pushing, and more frequently pushing into this space. I'm keeping a close eye on that effort, just for using Kibana to do some basic metrics and reporting from the system. I can't help but feel that there's a possibility of introducing, say, some simple scripting to say, let's create a process to take any data, all these observations and encounters that are being created in the system, stream them out into a Lucene database, and then create, maybe some scripting to say, okay, I'm going to write a little JavaScript or whatever the JS 122 the standard, write a script that will take any piece of data that's in that Lucene index, transform it into something, either derive some new information or transform it in a way that's useful to me, and store it back into Lucene as another document. And that could become a kind of generic approach that could power reports, some almost immediate reporting off the data. Anyway, and that's a solution that's also very parallelizable. So we just haven't gotten to where we've had anybody able to, or we haven't coordinated ourselves to kind of get that developed. So I think one of my to-dos is try to help draw out some design, or get some ideas out. We'll see. I don't know how helpful, or if this was helpful at all. I know you guys had interest in reporting probably more so than the specifics of the data model, but happy to have additional conversations. If we really want to get into some of the details of reporting, there's probably other folks other than myself that would be helpful for that. Any other questions from folks?
No, thanks a lot, Burke.
Thanks, was really helpful.
Yeah, so if there's additional questions, maybe it sounds like you've got some questions around porting. Maybe we could, in OpenMRS Talk, have a little bit of that discussion, and we could arrange another one of these, do a deep dive, maybe on specific, towards specific topics or questions that would be additionally helpful to you. I'm happy to help arrange that. All right. Well, thanks, folks, for joining. I do have another meeting I'm going to have to run off to. I've recorded this, and we'll get it posted to YouTube if anybody wants to look at it. And happy to help coordinate another deep dive use this OpenMRS units together. I think at the end of that is going to be more live today. So I appreciate everybody's efforts.
Thank you very much.
Thank you.
Thank you very much.
All right. Cheers.
Bye.